Hi guys, welcome back. If this is your first time here, please make sure to like and subscribe, and make sure you click on the bell icon so you can get notification for when I release a new video. Make sure you comment, because when you comment, like, and also subscribe, it helps me create better content for you. In today's episode, we're going to talk about the distributive property and a better way of multiplying binomials and trinomials. We're going to look at problems that look like this and problems that look like this, and how to go about multiplying them in an efficient way. So please stay tuned. In college algebra, there are certain topics that are made easier with time, meaning that if we first learn about a method, it can be confusing and overwhelming, especially if it's the first time you're looking at it. It's 14, 3, 14. A very straightforward property, but sometimes in the wrap-up of things, got very confusing, side by side with all the terms. So enter the box method. The box method makes the distributive property look like the hardest thing in the world. Looks like climbing Mount Everest, if you think that's hard. The box method neatly aligns the polynomial expressions, either binomial or a polynomial, 3 or 4 terms, in a box, a matrix. The matrix terms, or the area of the box, is determined by the number of terms that you have in the polynomial. I.e., if you have a 3-term polynomial multiplied by a 2-term polynomial, your box matrix would be a 3 by 2. 3 columns across and 2 rows down. You would neatly align the polynomial expression directly above the box. On the side, you would align the binomial expression. Then, like in grade school, in most composition books, do they still have that anymore? You would simply multiply the columns by the rows, ultimately leading you to a clear, concise answer, because all your terms are in boxes. Those boxes can be added or subtracted, like terms can be combined. So let's look at an example to make things a lot simpler for us. Let's look at several examples. Let's look at the standard 3 examples. First problem, make sure you like, comment, and subscribe. Now, we can get out to the problems. Let's start off with an easier problem. Again, let me bring it back the charts. This problem I would rate 2. Simply multiplying binomial by binomial. In fact, all the problems here should be rated a 2, as I am getting them from a freshman curriculum at a college, community college, locally. So the first problem states 6n plus 3 times 6n minus 4. If you look at this, you can see that there are 2 terms. So this is a binomial by binomial. As with all other problems on this channel, both math or chemistry, we have to first start off with our rules. The rules for multiplying using the box method are quite simple and are essentially only 2. The first rule states, line up your terms or expressions that you're going to multiply, so in both the rows as well as the columns. Step 2, multiply. Cross multiply, just like you did in the old composition books. You want to multiply your row by your column, until you have terms. Step 3, there's 3 steps actually. Combine your like terms until you have an answer. Until no other terms can be combined, that will be your answer. So, knowing that, let's start with our first problem. The first problem is going to be 2 binomials. 6n plus 3 times 6n minus 4. Since we have 2 terms in the first expression and 2 terms in the second expression, in a 2 by 2 matrix. Multiplying this matrix is also quite formulaic if we follow our rules. We want to be able to align one of the terms in the top of the column and the other terms on the side of the columns. Then we multiply through. So let's do that. If you look to my left, you'll see how it's lined up. And when we multiply through, we get 36n squared minus 6n minus 12. That's the product. Wow, that was easy. Let's try another level 2 problem. Check that meter. We have 3x minus 4 times 4x plus 3. We align both our columns and our rows. We get in the box 12x squared in the upper left minus 16x in the upper right over 9x in the lower left and negative 12 in the lower right. Combining our like terms diagonally, the negative 16x and 9x, we get negative 7x. So the final expression will be 12x squared minus 7x minus 12. That seems to be a lot faster than using the other method. So now let's try a problem where we have a trinomial by a binomial. FOIL can't help you here. Problem 3 reads 7r squared minus 6r minus 6 times 2r minus 4. Again, we want to be able to do this using the steps we highlighted in the beginning. We need to create a matrix. In this case, it'll be a 3 by 2 since we have 3 terms in one of the algebraic expressions and 2 terms in the other. We're going to want to align the terms, 1 to head the columns and 2 to head the rows. In this case, let's let the trinomial head the column. It's going to be 7r squared minus 6r minus 6 up top. On the side is going to be, left side that is, 2r minus 4. Again, each expression in the term, or each term in the expression, is going to have its own column and its own row. That way it makes things a lot simpler. Now, the only thing we need to do is combine our like terms. We can easily do this and see this because they're isolated in boxes. The isolation of the boxes makes things easy. After we combine the like terms, taking into account the negatives and the positives, we're left with an expression of 14r to the third minus 40r squared plus 12r plus 24. That was our third problem. Guys, let's stop here so we can recoup. Below, I'll leave a link to a sheet that you can do to practice in order for you guys to get better. Kuta software is an excellent resource for you guys to actually do by hand a lot of different algebraic problems. It cuts through the fluff, it cuts through the bluff. It just gives you the raw problems. You can practice the procedures that I outlined here once you print out some of the sheets below. Again, mathematics is about practice. The more you practice, the better you get. Please make sure to like, comment, and subscribe. If you have a further question about the box method and a problem from the resource that I linked below, please don't hesitate but to comment, even if you comment with just the question number and the reference sheet, and I'll be sure to go over it in the next video. Again, as always, I'm a knowledge guy, AKG, and I'll see you next week.